Hey everybody, what's up? I'm Meaghan Ziemba for MTDCNC, and I'm here in Wisconsin, my home state. Yes, I'm a cheesehead. No, I'm not a Packers fan. Everybody can be mad at me for not being a Packers fan. That's totally fine. But we got invited to Chippewa Valley Technical College by QualiChem. We're going to talk to them a little later on. But right now, the star of the show is Dave Thompson. Hello, Dave. How are you doing today?
I'm doing great. I don't know if I'd go as far as I'm the star.
Oh, you're the star.
But I'll give you any input I can give.
So we're here to talk about the program, the CNC machining program that you have here, which is really exciting because, as you know, the United States has a skills gap, and you are one of the main players that are really helping generate more of that next generation workforce. So can you give us a brief description of what your role here is at CVTC, and then can we start talking about the CNC programming here specifically at the college?
Perfect. First off, thanks for having me. And here in Eau Claire, Wisconsin at Chippewa Valley Technical College, in our machine tool program, the offerings we currently have is a 1 semester CNC operator, a 1-year CNC operator, and a 2-year machine tooling techniques program.
Okay.
So the classes are scheduled Monday through Thursday, and so the students can have the opportunity to work a Friday, Saturday, Sunday, or not work at all. It's up to them. Programs are set up in 16-week semesters with an 8-week break between semesters to focus on job skill or skill building in the manufacturing world. We focus on machining. We start off with basic machines. Right behind me, we got some engine lathes, and we use these to focus on building the skills of turning processes for machining.
This is like really vintage stuff too, because these are the old school machines. But I think that's one of the points I want to touch with you on. You know, why is it so important as a teacher for CNC machining to really teach your students the very basics of machining?
This is a skill building. Like, the analogy I can give you is the ABCs. Do you start talking right away, or do you learn the ABCs first? We have a base knowledge of the ABCs before we can actually start reading books, things like that. So we look at these basic manual machines as skill building. And being a competency-based program, we start at the very base level of competencies, and them competencies build on each other to keep moving to build that skill of turning for the lathes and milling on the Bridgeport machines that are also right off to my left behind you. At that point, then we can start using those skills with the CNC machines.
So walk us through what a typical journey of a student here would be if they decided to do that full 2-year program. So you mentioned first semester, they would start on the basic type of machines and learning that basic skill set, which would really help with their critical thinking once they get to the bigger machines. But give us a general idea or a brief synopsis of each stage of that journey.
Perfect. So we talked about that first semester. Along with that first semester, they have the blueprint reading, and then a precision measurement. They learn how to use the measuring tools. With that precision measurement, we have coordinate measuring machines, so they can use that CMM as a tool for measuring their parts. After that first semester, learning some base knowledge of machining, we move into the CNC machines. We start them off with the CNC mills, and they learn the basic setup, operation, and do basic programming of the CNC mills using the foundational skills they've got from the manual machining. Also, with that second semester, they spend 8 weeks on the CNC mills, operating, setup, basic G&M code, and then they move into the CNC lathes. Once again, learning the machine, setting it up, doing the basic programming of it. For that part's the basic knowledge that they learn on these old solvents, they apply to them CNC lathes.
And they're also doing the blueprint reading at that point too.
Yep, from first semester, everything is reinforced from that competency base. So they learn how to read blueprints in first semester. Moving in a second, the blueprints will start getting more complex as the competencies build, getting into the geometrical dimensioning and tolerancing with that. It starts in first, but it continues through second.
Okay.
Now, with second semester, we also start going into the CAD/CAM systems. The system that we use at Chippewa Valley Technical College is MasterCam, and that's the most prevalent in our area. So they learn the basics of the MasterCam system, wireframe, basic tool pathing, so they can start using the computers, the more advanced technologies with the CNC equipment.
So when you say that's the most prevalent, does that mean that's basically what students anywhere in a community college or a university environment would learn from, or is it prevalent in terms of that's what manufacturers in this area are using to make their parts?
Yeah, it's the manufacturers in this area.
Okay.
It's the most prevalent master or CAD/CAM systems, and there's a wide variety of CAD/CAM systems, and we focus on just the one system because once they learn that system, they can start applying it to the other systems that may be out there
Okay.
with the employers. For us, our CNC machines are mainly Haas machines, and we look at that competency of learning the processes of machining. They can take that knowledge and apply it towards different types of machine tools like a Makino, an Akuma, things like that, so they've got that base knowledge.
Yeah.
One of the basic analogies I use is driving a car. Once you get your learner's permit, you learn how to drive a car. Each car you drive may be slightly different, you know, the knobs, the windshield wipers, whatever it may be, are in different locations.
Yeah.
As long as they know how to drive, they can start using that knowledge to different models, i.e. the CNC machines. It's a different model. The buttons may be in different locations, but they know how to machine.
Right. But again, that's where that basic knowledge that you're starting
Yeah.
out with in first
Yeah.
semester really comes through and helps them shine in those particular areas. So once they got the Mastercam software component down, what's the next step in their journey through this program?
Thank you. The next step is going into third semester. That third semester, we start doing advanced things.
Okay.
For instance, for the CNC lathes, we have CNC lathes that have live tooling. So they start G and M code the live tooling, and also we have another Mastercam class for CAM for lathe to use that live tooling in a CAD/CAM system. Because the manufacturers in our area, most of their lathes will have live tooling.
Okay.
And our goal is for that person to be employable, and along with that, the machines we have are the same industrial machines that they have in industry.
Awesome. And some of your students are even working right now.
Yes. Our students, the ones that are working are the ones that want. If they're not working, it's because they want to focus on their academics. The nice partnerships that we have with some of our industries is that they do tuition reimbursement. So a lot of our students will graduate debt-free.
So let's touch on the partnerships really quick before we get into the next step after they have some experience on the complicated machine. So I noticed that you have Haas
Yes.
all over the place. We were invited here by Qualichem, and then I saw a Makino machine,
Yep.
ADM machine back there. So what is the process for CVTC to really kind of generate some of these processes or these partnerships? Like, what are you looking for in a qualified partner that's really going to help elevate the program that you have here?
The partnership that we have with Haas is first the educational discounts when we purchase machines. Right now they have a 10% for education for schools, things like that. They also, through the Gene Haas Foundation, they also put on national conferences for all educators, university, high school, technical colleges. We all do an annual meeting, and it is located at different locations through the nation. They support that. They help, we share best practices. Also through the Gene Haas Foundation, they're very supportive for education. And we just recently received a $40,000 check from Gene Haas Foundation to give to our students to help them through the finances of education.
Which is amazing. So explain that part of it, because you were talking about that earlier, and I was like,
Yeah.
man, if I had that opportunity, I would not be in the career I'm in
Our
today.
current process for that is that the students, now there's two criteria. The students have to have a 90% attendance or better and a GPA of a 3.0 or better to qualify for the $1,000 per semester.
That's-
So after first semester, they can get $1,000 with those two criteria. Second semester, same criteria, a GPA of 3.0 and attendance of 90%. Then also third semester.
But what an incentive
Yeah.
to have to a younger generation. And you know who else would get excited about those types of incentives? Parents.
Yes.
For sure, 100%.
When we give tours, we always ask the students to bring their parents in, because a lot of people don't know what machining is. That's probably one of our biggest obstacles. But once they come into the program or come into the shop for a tour or whatever it may be, they start seeing it. These are real live machines that they would be running in the industry, and we start at that base level. just keep building blocks with that competency based.
So you have Haas, you have Makino, you have Qualichem, but then you also have the partners with the manufacturers that are inviting these students to come in and actually work with them in their
Yes.
facilities. So how important are those specific partnerships to really keep programs like this going?
The partnerships are really nice and they're important. The industry helps guide our curriculum. So we have advisory meetings twice a year, and the owners, shop owners, leads, whatever it may be for the different shops in the area, we'll meet and we'll discuss, what are trends in industry? What are they looking for? For instance, I talked in that third semester live tooling. Industries, when they buy a CNC lathe, 9 times out of 10 it'll have live tooling.
Okay.
And keep going from there. Also, with our industry partners, the tuition reimbursements, things like that, and that's what helps build the strong programs, is the support from them financially and with the curriculum.
So your curriculum is changing as the industry changes.
Correct.
That's awesome. So then let's continue the student's journey through this program. We went through the complicated stuff on the CNC
CNC
machines.
lathes, we left off with the live tooling, and that second part we get into more advanced CNC milling and heat treatment and milling and grinding. The grinding aspect of it, we have, I'd mentioned earlier, it's 0.3 of a thousandths, and to put it in layman's terms, that's 10 times smaller than a human hair, that students hold perpendicularity, flatness, and parallelism.
That's awesome.
Yeah.
So then what happens after that stage? Or
Yep, thanks. After that third semester, we find out we got some advanced things. Now we want to get them really ready for employment to be a machinist.
okay.
So in that fourth semester, we move into 5-axis machining. With that 5-axis machinings, they do the G&M code of it and also the Mastercam portion. So third semester, we either had that cam for lathe and we have an advanced Mastercam. And then fourth semester, we have cam for multi-axis, which will have the true 5-axis machining with Mastercam. We have trunnions that add 2 more axes onto our VM2s, that it's a regular 3-axis machine. We had an A and a B rotating axes, so they learn that, and then they'll also move into, you had mentioned we have some Makinos. We also have exposure to sinker EDM, electrical discharge machining, and wire EDM. So they set the machines up and they do some real basic programming with Mastercam software, and also some of the G&M codes that they'll set up with the Makinos and run them.
So can you give us some success stories from this particular program? You mentioned earlier before, how long has this program been running?
This program's been running probably from the late 60s.
And you were part of the program. You actually went through the program yourself.
I actually came through the program in 1990. I know I'm dating myself. But then I came back as a faculty member in 1997. So I've been here pretty much ever since.
So let's go back maybe the last 3 or 4 years, how many students have created successful careers in CNC machining or manufacturing from this program?
From this program, I've got, actually on our advisory committee, I'm at a point now where some of my students own their own companies now.
That's
so
awesome.
we got some companies in the Chippewa Valley that actually were students in the early 90s, even into the early 2000s, that are running their own businesses. I can think of 3 right now, and I'm not sure if I'm at liberty to mention their names.
That's okay, no worries, but that's awesome.
Yeah.
That's great results. So to close this conversation off, what are some of the main challenges that you're facing right now as a tech teacher, as a CNC machining program? Like, what are your biggest hurdles that you're facing?
The biggest hurdle is exposure and people knowing what machining is.
Okay.
Because right now our enrollments are low. A lot of it is because the students have not had any exposure, being it in high school, relatives, just knowing what actually machining is. If you ask somebody what is a machinist, you ask myself, we make stuff. But what do we make?
Right.
Anything that's man-made, a machinist had something to do with making it.
Yeah.
We're 1 degree away from everything that's man-made.
That's awesome. So what would your biggest ask be then for anyone tuning into this video? How can they continue to help these programs thrive so that we can start closing those skills gaps?
Start exploring the manufacturing in your area. Start educating yourself and see what kind of opportunities there really are in the world of manufacturing.
What do you specifically need from manufacturers though, and also other business leaders who are not within manufacturing?
I'd say continue with what they are doing, being involved with your local technical colleges, that specifically the support. That's the biggest thing. Any support that we have, that's probably the biggest thing.
I'm going to be blunt and just throw this out there, but I think one of the biggest ways you could, if you're not within manufacturing specifically, is donate some money as well.
Yeah, money always
be part of that funding part of thing.
My mind wasn't even
I'm
going
just going
there.
to throw it out there because that's one of the important things. Because you have a lot of great machines here. Machines are not cheap at all.
Education systems don't have the
right,
money.
Right.
We're very fortunate. In this shop, we've got 34 Haas machines, along with 2 Swiss machines. I did not mention them in 4th semester, but we do. The students do set them up and operate some Swiss screw machines, along with the Meaghan wire EDMs. It's taken us years and years to build this shop.
So I'm going to talk to some of your students later on, and one of the questions I'm going to ask you now. So why Chippewa Valley Technical College?
We are one of the top technical colleges in the nation. We've had students come from Missouri because they hear about our program and they want to come up and get the education that we offer.
Well, Dave, I want to thank you for taking time out of your day to speak with us at MTDCNC. Your shop here is amazing. I'm really excited for your students because you are setting them up for success. And the way that you can help shops like this be set up for success in the future is to really get involved. So let's start closing the skills gap that we see here in the United States. And let's thank the machinists that are running all of these machines and get involved as much as you can. We're going to talk to students soon after this, so stay tuned because we got some more great stories ahead.
Thank you.